So welcome back to our clustering lessons in Python using scikit-learn, and we just learned how to use a simple Kmeans algorithm to fit some data. This means in supervised manner we fed some features, in this case 4 columns of data, and we got some answers. We said we want 3 clusters, and we actually got 3 clusters. So that is one of the problems with Kmeans. It works fantastically as long as you know how many clusters you have. Right, if you don't know the number, which is usually the case actually, you'll need to do some more exploration. But let's first see if we can interpret this data, see how well did we do. Let's compare compare results with the actual species. Can we do this? Yeah, values, right, and of course we know that, right, we could compare it, not species, but we called it, how did we call it? Class, okay, yeah, class, okay. AI is not smart enough for this, I need to do it by hand. Remember, class is a specified name. Right, Aristotle, how can we do it? So basically we would need to assign these values. We say we would need to create categories, right, of these, create numerical labels for a species, something like, right, map, 0, 1, 2, right? That looks about right, yeah? Class, but not class, my species, I'll call it species label, species, right? Something like this, right? Because I don't want to, so I'm going to perform a mapping in pandas. We provide a dictionary of answers, right? What maps to what, and it will go through and perform this mapping, and I'll save it in a new column, right? And save in a species column, right? Okay, so a simple recipe on the 0, 2, 1 actually, more like it, right? Again, that of course in this case it's like I said, this is because we know the answer. Usually there's no problem because we don't know the answers, right? But so iris versicolor, let's see, yeah, versicolor was 1, right? In this case I will, of course, I'll go 2, right? Yeah, we'll switch it around, right, to be more precise, right? Right, let's see it. dv head, right? Yeah, 0, 0, of course you can do df tail, of course, df tail, let's see, df tail, we'll do the df tail skb, df tail, of course, you could see, of course, right, that, yeah, it ends up as 1. Okay, so now we can compare, compare species with our features, no, labels, sorry, labels, right, so with our labels. So now compare species with, now compare species and labels, right? Yeah, well, print accuracy. So we want to compare where they match, print them matching, print them side by side, or print the number of matches, right? So let's do that, right? Kmeans sum df species equals kmean labels. Let's see. We can see 134. All right, so our accuracy, our accuracy is, yeah, well, again, that's is what, 134 divided by length, right? Same thing, so it's 134 is 134 divided by 149, of course, right? Not, well, we have one again. Let's try this. Yeah, about 90%. So roughly 90% accuracy. So not bad at all, actually, right? And we can of course print the coloring. Well, the only problem is we have 4 features, right? So print the confusion graphics. No, let's plot the results using first matplotlib, first 2 columns, first 2 features, and color by labels, right? Right, so let's try this. Yeah, Kmeans labels, right? Scatter first 2 features. Let's see, right? So simple quick plot, right? Features all of the first 2. Right, we can see works well. The colors, completely horrible colors. Let's do something. Color map rainbow, maybe better. Let's do that. No, color map. What's color map? Doesn't have a rainbow. Color map. Oh, come on. Colors, maybe. Colors. I think it should be, I forget now, colors okay, I'll try it. No, I have to look up documentation. I don't want to look up documentation, so I will skip the colors for now. Hue colors maybe. For now, class. We'll need to look up the documentation to do. This might be for another part. To do look up matplotlib documentation how to color custom color the hues, right? All right, but okay, so that is of course the one for the features versus labels, and now of course we can also plot first two features versus species, right? All right, so this is of course same thing, except we use species, right? And should be same result. Well, roughly the same result, of course, and we can see the mismatch somewhere there, right? So it's not quite right. So this is what our model provided, and this is what the actual case, the truth, right? So there are about 15 error, about 15 of those. All right. So again, the main thing is to remember that you have a Kmeans does as many labels as you want, right? So what happens is that we can provide, if we say 4 colors, it can create 4 colors, right? We can create with Kmeans we tell how many clusters fine. So let's say we can do right. So for now, let's do right. We will do elbow method, right? That is actually right. So that's going to be something to do next, to do explore next, to do explore lookup, right? That's going to be next. But for now, I'll do 4 colors, 4 cluster of 4. You know, Kmeans. Let's create Kmeans object with 4 clusters, right? I can't spell, of course, here. Sorry about that. So yeah, Kmeans 4. I'll call it 4, right? You know, just to, or maybe underscore, right? Kmeans 4, right? Of course. And now I can fit 4, right? And now I can fit 4. I can fit the model, right? Right, features, and of course I can provide print labels, print the labels, right? Right. So again, notice, so 1, 0, 3, 2, 1, and of course, so now again, so the key issue is that again the difference is, so we can put the results, of course, right? Scatter for means. Let's try it, right? And we can see, right? So it came up with a new species. So Kmeans came up with a new species, a species of irises, right? Irises, right? So yeah. So again, so that is of course obviously. So in real life, we do not know the number of clusters. So that's something we'll explore next. What to do when we don't know the number of clusters. Thank you.